guys, we're live.
Well, good morning, everyone. Thanks for attending the webinar. My name is Mitch Kyan with Manley Communications, and just like to take a second to introduce our client, Utah DOT, Stan Burns, Michael Butler, Frank Pisani. We'll be doing a presentation this morning on the network-wide data management project that Manley's been a part of. Manley, just a little background on us, we've been around for 30 years, based in Madison, Wisconsin. We specialize in mobile data collection. So we've worked with Utah for a couple of years now. We were part of an RFP as far as providing the data collection portion of it. We've collected and delivered pavement data, photo log, mobile LiDAR data, and from the mobile LiDAR we provided asset inventory on various roadside assets. And we're worked with other vendors that Stan will get into probably more detail as far as being able to inventory the assets and help them manage the assets. And Utah here, Stan will talk about how they've managed them and planning on updating the new assets for 2014. And all the audio is muted. If there are questions, please feel free to type them in. We'll go over those at the end. And I guess that's all I have right now. I'd just like to hand it over to Stan. And again, thanks for everyone for attending.
Thanks, Mitch, for the introduction. This is Stan Burns, and we want to thank Manly and GTMA for providing us this opportunity to describe our journey over the last couple of years. Today's presentation, I'm going to talk about the data inventory project that we started with Manly a couple of years ago. Calibration of the mobile LiDAR, which was an added value. I want to spend some time with Frank Pisani, our GIS manager, to talk about how we've integrated GIS and the assets. And then finally, we're going to have John Guyman explain how we're integrating these assets into our design process. So the presenters today are Frank Pisani, GIS manager, John Guyman, rotational engineer with us, and then myself, Stan Burns, director of asset management. And there's the telephone numbers and emails if you want to contact us. First, I'd like to give you a little bit of background on Utah. Both Frank and I are transplants from the East Coast, and we came to Utah to ski, and we stayed. But the population is fairly small compared to most states, but it's growing very, very quickly. It's growing about 30–40% a year, 30–40% a decade, excuse me. We're a fairly large state, and UDOT has 5,800 center line miles, about 1,600 employees. I've embedded some links into this PowerPoint, so if you want to have access to the PowerPoint, Mitch and I will figure that out, and you can click on these embedded links. But what I was showing you in the beginning was a time lapse of SR12, which is a road down south. It looked a lot better on my computer than coming across the web. We were also checking that out. And I have a link to Skiing Utah Powder if you want to see why Frank and I came out here. But it's a beautiful state, as you can see, from the Red Rock Canyons to the high alpine peaks to Salt Lake City, nestled under the Wasatch Front. Why are we talking to you today is this project started because we couldn't answer this question. Are we allocating dollars appropriately? And for those who are from the DOT or the federal government, our biggest challenge is, one of our biggest challenges is, where should we spend the last dollar, and most importantly, why? Why should we spend it on signs, pavement, safety, maintenance, and mobility? We can't answer that question now. It's with technology that's evolving as we speak that we are being able to answer that question for the first time. The public is surprised that we can't answer this question. We can't say we should spend the last dollar on safety as opposed to pavement or bridge. And we haven't been able to do it because we didn't know what we had. And completing the Manly project, for the first time, UDOT knows what they have. And now we're integrating that information into our business system, so we'll be able to justify why the last dollar should be spent on signs versus mobility. So we have about $30 billion in assets, and that's a guess because, again, we didn't know what we had. So for the first time, we're putting dollars to all of those assets that we collected with Manly. And to give you a little bit of an idea, I have a quiz here. How many signs do you think we have? And then I'll be able to get back with you in about 4 months, but you can give me a guess on what you think the total infrastructure value is. Somewhere around $30 billion. But at the end of the presentation, we'll tell you how many signs we have. And 4 months from now, we can tell you the value, because for the first time, we know what we have. So I'd like to tell you a little bit how we started 2.5, 3 years ago. And we call this Cover Your Assets. So we're going to go through and we're going to show you all the assets that we are now inventorying and have an idea. And I have a couple embedded links here, the RFP and the contract with the data dictionary. So if you're interested in the RFP that Mike Butler and I started 3 years ago, it's on our webpage. And then the contract we signed 2 years ago with Manly is on our webpage, and they're in these links. So 3 years ago we wrote this RFP, and we wanted to collect the entire roadway system. So the contract was signed to drive both directions, all those 6,000 centerline miles I mentioned, about 14,000 driven miles. And for the DOTs, probably the most impressive slide is this one, and the bullets on the right-hand side. We got all of these groups within UDOT to work together on this project. And again, when I tell my spouse that we're getting all these groups to work together, she says to me, "So what? What do you mean, you don't work together?" And I say, "No, we don't. Traditionally, we don't. But on this project, we did." And I have to give credit to Manly. They had such a good product. They had such a great workstation that visually, people can see the vision. They can see the future. And it was easy for Mike and I to convince people across the DOT to work together. So maintenance, traffic and safety structures, GIS, IT, motor carriers, pre-construction, right-of-way, the regions, and us in programming. So this is probably the most impressive slide you're going to see. The DOTs will be impressed. Everybody else will say, "What, you don't work together?" So that's the power of this project, is instead of going out with multiple data collection efforts, instead of having multiple LRSs, multiple databases that never talk together, we have one LRS, one data collection, one integrated system where everybody can see all the information at the click of their mouse. And Frank will show you that, and you can play with it later on. It's all on the web. You can see all this information that we're going to show you. So how much data is it? It's a lot of data. We take pictures every 26.2 feet. There's 3 high-definition images, 2400 by 32. It's about 7 million images across the state. And then Manly was the only contractor that submitted a proposal with LiDAR. And for those of you who don't know what LiDAR is a little bit like radar, but it's light. And so there's this laser sensor that's sending out 1 million points of light a second. The light bounces off an object, it comes back to the receiver. What it's bounced off is it's all geolocated, X, Y, and Z. And so we have a very accurate inventory of all the assets, but it's a lot of information. It's 24 terabytes. And you can see on the right-hand side the scope. We wanted to know all the pavement condition, the geometry, all the visual assets above ground, everything you can see above ground, pretty much. And I'm going to go through those, give you an idea, a little bit better idea of what that entails. So here's a picture of I-215. It's a belt route, Salt Lake. It's heading towards the ski resorts. Frank Pisani put this together, but it's a great visual to give you an idea of the type of assets we collected on the Manly project. And so I'll just step through these, but as I step through these, you learn things as you proceed. And so we finished the first phase. The collection was in 2012. The second phase is going to be starting in this spring, 2014, and so we're going to add to what we collected, and I'll mention those. No matter how many times you do these things, no matter how many times you do anything, you always get better at it. you always improve. And as we've even gotten more people at the DOT involved with this project, they have asked us for enhancements. So I'll tell you those as we go. But the first phase, 2012, we collect the sign face, and that means the width and the height, the MUTCD code, what that legend is, the condition of that sign, good, fair, poor, the location of that sign, X, Y, and Z, and the elevation of that sign, the clearance of that sign, the sign support, the type of sign support, how far offset it is from edge of oil or the travel lane. What we're doing on the next phase, though, I mentioned that LiDAR, we're working with 3M, Manley, and Virtual Geomatics to see if we can correlate the condition of the sign to the intensity of the LiDAR coming off that sign. So we've been trying to do that correlation for about 6 months. We haven't solved it yet, but that's what next phase is going to try to do. Barrier. We geospatially located all the barrier, whether it's cable barrier, jersey barrier, guardrail. Geolocated again, the height of the barrier above the surface. The end treatments and all the specific end treatments of all the barriers. Walls. Here we have a retaining wall, but we did noise walls, MSE walls, retaining walls, bin walls. Lanes. We have now located precisely all our lanes, the correct number of lane miles, the width of all of our lanes. Shoulders, the same thing, the width of all of our shoulders, and also the composition, whether it's concrete or asphalt, and that's the same with the lanes. And then striping, whether it's skip or solid line, whether it's 4-inch, 8-inch. We did not ask them to geolocate this on 2012. We have asked them to geolocate it in 2014. Maintenance, which is a big partner of ours on this project, just wanted to know the quantity of paint. But now we're working with designers much more closely, and they want those skip lines geolocated. So phase 2 will be that.
It sounds like the link sent out is the old meeting, so there's a lot of people that are in the old one, so I'm trying to coordinate to get the new link sent out to all of them. So there's a handful of people that are sitting on the other meeting waiting. Sounds like Janine sent me a text, that's how I found out.
Okay,
So,
Mitch,
anyway, if you want
did you hear what Mike just said?
I didn't hear all that.
Mike, go ahead and repeat what you just said.
Because of the link changing, it sounds like there was a lot of people that are on the other meeting appointment. And so I've asked Janine to see if she can have all of them email me their email address so Mitch, you could forward them the correct link.
Okay.
And let's just forward the correct link on all these individuals, or does it have to come directly from you, and do they have to register for this meeting?
It can come. I sent the invite out reminder Friday and then this morning. So within that email, if you forward that to anyone, they should just have to go to that link and be able to log on. And it just takes a second to put your information there, log on. So if you want to pause for a minute and let people do that.
So are you, they don't have to sign up then? They can just, anybody can click that link and they'll automatically come in?
Well, they have to put in some information, just like name and who they're with. There's some information they have to enter into it, but after they put that in, then yeah, it should be able to open up right away.
Okay, then I'll just have Janine verbally tell everybody on that appointment to email me, and I'll just forward them this link for this meeting, if that works.
Okay.
Okay, sorry for the interruption.
No, thank you, Mike. Thanks, Mitch. We'll see if we can get those other folks to the right link. But in the meantime, I'll continue with the assets that were collected. So here's another image of southern Utah, just outside of Moab, down by Arches National Park. And the assets that we collected there are, the rumble struts, both inside lane, outside lane, center line. And these are, again, not geospatially located, but we'll ask them to do that in the second phase, we just asked them for presence or not. And so, so then the next thing we did was collected surface areas, and that's really important from our pavement management standpoint. How many areas of concrete do we have? How many areas of asphalt do we have, both on interstate, national highway system, or secondary roads? Pavement condition. We collected all of the cracking, whether the length, the width, and because we're working with PaveMetrics works with Manley. PaveMetrics now has 3D technology, which is the depth of all of these cracks. So we know all the cracking, the width, the depth, and the length on all roads across the entire state, plus rutting, faulting, spalling, raveling. The medians, the composition, the width, and the geometry, the horizontal, vertical, cross slope. One thing we're doing on the second phase is, the first phase, we got the geometry from the IMU on the Manley van. We've asked Virtual Geomatics to work with us to determine the horizontal, cross slope, and vertical from the LiDAR. In other words, I'll point to it with my mouse. LiDAR can tell us the edge of that oil and the elevation. They can also tell us the edge of oil right here in the elevation. So we'll be able to get precisely the cross slope across the entire road. And they're also going to fit the horizontal curve into this, mathematically, into that curve that's described by the LiDAR. And the elevation. Here in Utah, our roads are anywhere from about 10,500 feet to 2,000 feet. And the assets, design, maintenance is all highly dependent upon if you're at 2,000 feet above sea level or 10,000 feet above sea level. Typical intersections, these are the type of assets we collected, every intersection. Pavement messages. Here you can see a bike lane, you can see an arrow. And the crosswalks, I should have mentioned that. And we also noted bike lanes in general. Drainage, drop inlets. Islands, the type of islands. Here we have edge type, but it's a curb and gutter, as you can see, but it could have been a roll gutter. Signal cabinets and power pedestals for the signal. The location of all the mast arms, the supports, the signal heads, how many signal heads, whether it's a 5-section or a 3-section. And then some of the things we're asking for that are in an addition in 2014 is the presence of sidewalks, the location of sidewalks, luminaires right here, overhead power lines, location of manholes, and in here underneath this car is a monument, a survey monument. We also have valves for water, gas. We're going to locate all of those. The designer's one of those. So that gives you an idea of the assets we collected. And I always, for those who've seen this presentation before, I always show this graph. And because we can collect information now, because we know the location of all the cracks, all the rutting, all the faulting, we can put that into our pavement model that we use Dayton DTIM's product. And in this, what I'm showing you in this graph is 2008 to 2017, the condition, the statewide highway system, the condition of the roads, what they were 2008 to 2012, and what we expect them to be 2013 to 2017 based on $188 million a year. We can only do this, we can only run these advanced models if we have good data. And we haven't, historically, we didn't have good data until about 2008. So it's our biggest asset we have, pavement. It's our most important asset we have. And now we're able to show with confidence what we think the future will be with our pavements if we spend $188 million a year on preservation treatments. Another, Frank is going to show you more of this, UDOT, what we call it in U-Plan. But what I'm showing you here in this screenshot are all the signs in the small town of Cedar City on state roads, the location, and the condition of those signs, good, fair, poor. The magenta are signs in good condition, the yellow are signs in fair condition, and the red are signs in poor condition. Remember our quiz is how many signs did we have, and we didn't know how many signs we had, let alone the condition of those signs, where they were, the MUTCD code. Another benefit of this project is working with traffic and safety. We're working with ESRI, AAA Foundation, MRI Global, and we're developing a safety management system. Frank will probably have time to show you this. We geolocate all our crashes. From Manly's data, we're getting all the horizontal vertical curvature. We include our skid data in with that. We know where all our safety assets are, and I'll just point them out to you. That we know the width of this lane. We know that that's a 4-inch line. We know the rumble strip. We know the width of this inside shoulder. We know the height of this guardrail. We know that there's cable barrier on the other side. We know the type of end treatment there. And then what ESRI, AAA, and MRI Global, they're also going to locate societal impacts. And they could be, this is a high school. High schools are, kids like to text and drive, right? I could have shown a bar. I could have shown the ski resorts where Frank and I go skiing. There's a relationship between all of these, crashes, roadway geometry, the physical features, and societal impacts. They're going to put all that together into a safety management program, and from that we're going to be able to prioritize. If you spend X dollars on your system, these are the type of projects you should do, and this is the reduction in fatalities and serious injuries we should expect to get by spending dollars at the right location. Remember that stick graph? Where should you spend your last dollar? I had it globally. Should you spend it on safety? Should you spend it on mobility? Should you spend it on preservation? Here, we're going to be able to say where we should spend our last dollar from a safety standpoint and what the impacts will be. Lastly, I like to talk about how we added value to that point cloud. That point cloud is for asset extraction. Its accuracy is plus or minus 1 meter. We've been able, working with virtual geomatics, to get that accuracy to plus or minus 3 centimeters. So we took what they call mapping grade LiDAR and got it down to survey grade, and we are designing to it now. And the report is embedded in this PowerPoint, and you can see it there, report web access to LiDAR point cloud for design. If you'd like to have that report, we'll give you the link. But it was a long process. We've been working on it about 1.5 years, and we're just about there. So I'll give you a little bit of a story of how we got there. The first thing we had to do was improve the relative accuracy. There was a lot of noise. That Velodyne 64 is the sensor that Manly uses that has 64 individual laser heads. They all send out individual points of light, and they're not calibrated precisely. And we didn't know that at first. So this is what the non-calibrated surface, that's concrete surface on I-15 here in Salt Lake. It's really not that rough. But when it comes out of the sensor, that's how rough it is. It's plenty good enough for asset extraction, but not for design. And so it's plus or minus 8 inches of noise. We couldn't do any kind of design to it. We couldn't do preliminary design. We couldn't do scoping design because we couldn't figure out where the edge of that barrier right there, or there's a barrier there, touched down to the concrete pavement. So Virtual Geomatics came in and they figured out a way to calibrate Velodyne's sensor head. And this is the result. This is a graphical illustration of how much they were able to clean it up, and they got it down to about plus or minus a half an inch of noise. Now we can do concept, scoping, and preliminary design with the cleaned up the noise filter on those 24 terabytes of data I talked about for LiDAR. The next thing we had to do, we had to improve the absolute accuracy. We had to tie the X, Y, Z to the correct latitude, longitude, and elevation. And again, working with Virtual Geomatics, this is the way we did it. Our surveyors went out before Manley drove the road, and they set control. And this is the painted control located in the cloud. And then when the surveyors brought in the actual X, Y, and Z, you can see the offset. That's about a meter. What they did is they ran their software. They transformed the entire point cloud. They didn't do rubber sheeting. They have a different process. And you can see that when they did their transformation, they got to this accuracy of plus or minus 3 centimeters. So we did this, and there was a lot of questioning whether this was accurate or not. So a year ago, we hired Meridian engineers here in Salt Lake to verify, check what Virtual Geomatics did for us. We have a project, Silver Creek to Wanship. It's an interstate I-80 project. It's just east of Park City. We're going to rebuild the road, fix the supers, fix the drainage, rebuild the entire pavement section. And so what we did is we hired them to do 2 types of surveys. We asked them to do a traditional survey, cross slopes, total stations, and we asked them then to set up test sections to verify the information we were getting from Virtual Geomatics. And so this is a stick diagram of the roadway section. You can see it's about a mile plus 148 to 155, about 7 miles. Has 4 different structures involved. A canyon area, or about 6,000 feet. So this is a representation of test area number 4. As I said, there were 6 test areas. You can see these are the UDOT's control points that we set up before Manley drove the road. This is Manley's point cloud in air. And then there's these test areas right here, the area, a test area. This is using traditional survey methods. This is using terrestrial LiDAR over here. And here you can see the cross slopes, traditional cross sections that Meridian Engineering did every 50 feet. And they used a robotic total station to do those cross sections. What Meridian also did to check and verify the accuracy of this point cloud, they actually found features. Here you can see a sign, and right below it you can see the LiDAR. You can see the elk or the deer sign, and you can see the LiDAR right below it. So what Meridian did is shot the corners of those signs. They shot the top of the guardrail you see, the snow fence, and they checked specific points. Their points versus Virtual Geomatics transform point cloud. And then finally what they did is we ran 2 different DTMs, one with a traditional survey, one with a transform point cloud. And in this PowerPoint, I show at the very top bubble the major contour, the Cayenne, the conventional survey, and then right next to it, the blue, call it LiDAR, that's the transform LiDAR. So then we checked that. So we did several different checks, and the next is the results. The graph to the left, this is the DTM check. When we did the DTM check, 93% of the points were within a tenth of a foot. And to give you an idea of the size of this, this is 300 million LiDAR points. This is 11,000 survey points. And then the graph to the right, 85% of all extracted features were within 3/10 of a foot. Whether it was a sign, a guardrail, a snow fence that was 300 feet from the LiDAR head, a sign that was 50 feet or 100 feet from the LiDAR head. So the summary of all this is Meridian engineers estimated that the cost savings were 24%, time savings 22%, safety. How do you measure safety with people not having to be out in the field? But they felt a lot safer being on the edge of the road. Accuracy was plus or minus 3 centimeters. We have 2 other pilot projects that are just completed now. They're both on I-15 on the Wasatch Front. And we have a report that's in draft form on those 2 other projects right now. So I've come to the end of my presentation. I'm going to turn it over to Frank Pisani. And Frank's going to describe UGATE, UPlan, linear bench, and that web address, just think of data.udot.utah.gov, and you can access this along with Frank or afterwards. Frank?
Thanks, Stan. I think we had a little bit of mix-up with the web address email, but I think we've sent the new one out to everyone, so I'm hoping that everybody has the new web address. And it reminds me of I think a quote that Einstein said, life is like riding a bike. You gotta keep moving to stay forward. So we're just gonna keep plowing ahead with the webinar here and move forward. And so to pick up where Stan left off, you can see this project is a really big project, a diverse project. We've incorporated a lot of different people from a lot of different disciplines in the DOT and also external. It's really snowballed into a lot of different efforts. And I think that myself in GIS, I don't think there was anybody more excited about this project than me. It's with a growing GIS unit. It was really exciting to get a big pile of data to support our efforts and our applications and really what we think we can do with GIS as a business intelligence tool. So what I'm going to do for the next half hour here is I'm going to show you our UPlan application. I'm going to talk about some of the tools that we can do with UPlan now. I'm going to talk about one of our other straight line diagram applications, and then I'll get into really just covering some of the back-end, more enterprise data architecture type stuff. Kind of the heavy, a little bit into the heavy IT stuff. But we'll save that for later, and we'll start with the fun stuff first here. So this is the UPlan website as it exists in the arcgis.com domain. So we have purchased a subscription to arcgis.com, and we're using what we're calling UPlan as really our enterprise GIS tool. We have our winter persona on here. We do a lot of snow management in the winter, and we like to change our home screen up here to really represent what the DOT does throughout the different seasons. And right now is a lot of winter management. So just to start with UPlan, UPlan started out of a need. It was out of a need to deliver better and more accurate and more timely information to the staff, the public, and decision makers. And we felt that UPlan really needed to be a GIS tool because the DOT is natively spatial. Everything we do at a DOT, from projects to funding to accidents to permits, can be mapped. It can be tied to a section of road. So we feel that GIS really lends itself well to being an enterprise tool for data management. So we really developed UPlan around a GIS-centric approach, and that's where we've gone. And we've moved to ArcGIS.com about 2 years ago, and we're really happy with it. So as GIS manager, like I said, I was really excited about this project because it's really my job to make sure our spatial data is available and authoritative. So I'm going to show you how we're delivering this big pile of GIS data that we receive from Mandley through these applications. One of the things that I want to pick up on what Stan mentioned here is part of the deliverables of all of those assets that he covered is one of the deliverables that we asked from Mandley is for this data to be provided in a GIS format. So not only did we have tables of information that they gave us, but also to deliver it in a GIS format. So we wouldn't have to create all the spatial data after they delivered it. So I'm going to show you now what we have is a gallery of information. So this is what we're calling our asset management gallery, and this is one of the tools out of ArcGIS.com. And what this is just a collection of maps that represent really each asset that we collected through this project. So as you can see, we have barriers, intersections, medians, pavement messages, rumble strips, bike lanes, shoulders, pavement striping, surface areas, lanes, signs, and then pavement information. So we thought this was a really good way to just try to focus all of these different items so people could evaluate each item independently, do their own QC, and really try to learn about the data. It's been about 6 months since we've had this data available, and people are really starting to wrap their head around it now and starting to play with it. So now I just brought up our pavement management map, and I'm going to turn off these layers real quick. And pavement was one of the big drivers of this project. We've been collecting pavement data for a really long time at UDOT. We've been using it programmatically to plan our preservation and maintenance program. And let me just refresh. There we go. So what you're seeing here is our overall condition index, and this is a metric that UDOT develops to manage the health of the roads. It is built upon a number of different indices, like cracking and IRI, faulting, rutting, all the different variables that we collect about pavement. We combine into one overall measure to calculate the health of the roads. And as you can see here, like I said, we've been collecting this data for a really long time. What we're showing here is just a 10-year chart of this section of road and its pavement condition over time. As you can see, in 2012, this pavement condition dropped a little bit. As you can see here, it went from 2010 to 2011. You can see that it increased, so we must have done some sort of treatment on this section of road out here that's highlighted. So these are just some kind of little tools here that we that are available in this mapping platform to just kind of show things in a couple of different ways, on a map and a graph, in just a matter of a couple clicks. One of the challenges that we have at UDOT is taking this data and making it work for all levels of the organization. So making it work for decision makers at the senior level to staff level to actually make project level decisions on, and then also from the public. So we're able to put one layer of data like this pavement condition on the map. We're able to see its existing condition and historic conditions, and then we're able to add data from other systems. This is data from our project management system, and these are pavement and preservation and rehabilitation projects. And this is live data, and it's saying, hey, this area we noticed we had some pavement problems, and we're addressing that. We have a project going on that's going to address that issue out there. So we're trying to use these mapping elements to really help people see current condition as a dashboard to see what we're doing on that section of road, and then also look at historical data. So what I'm showing you here is historical data that we have talking about our last surface treatments. As you can see, when I turn this on, I got a little time slider down here at the bottom, and I'm going to have this cycle for 4 years. And as you can see, these sections are turning over. So what I'm showing you here is pavement treatments that we've done over time. So we can see historically when's the last time we did something on that stretch of road. And then as you can see, I'm going out into the future here because we also use this data as a forecast mechanism to model and predict, where we should do our next treatment. So we're trying to use, one map element to bring all this different data together and then be really one common operating picture for many people to go to make different types of decisions about pavements. So pavement was one of the big successes that we had with U-Plan early on. It was a low-hanging fruit. We had a lot of data, and really it was an easy thing to put on a map. We just started, symbolizing it, good, fair, poor, and immediately people could start making decisions. They could start seeing their data, and it was a big win for us. So Stan mentioned signs. Signs were really one of the first things that we were really excited about getting from Manly. Like we said, we didn't know how many signs we had when we started this project. So we were really excited to get really good, accurate information about our signs on the road. And let me bring up this little overview map here. And this is State Route 190. This is in Big Cottonwood Canyon that goes up to Solitude and Brighton ski resorts. And you can see a couple of these little dots in the map here. Let me change the base map here to, maybe this might help via the webinar. You can see this maybe a little bit better. So what we have here is we're showing just signs named good, fair, poor condition. And you can turn off each sign, condition. So now we're just seeing what signs are in good condition. Now I'm showing you what signs are in poor condition. And then we had Manly collect a lot of descriptive information about each sign, like Stan mentioned. So we can see it's in poor condition, why it's in poor condition, it's an obstructed view, what type of sign it is, the height above the roadway. And now that we have all this information in a GIS format, we can start doing some good queries and really some GIS analysis to help us solve the problems that maybe we're having with signs. So I'm going to switch to a different I'm going to switch to a different layer really quick, and I'm going to do a couple of queries here to just show you how we can use this. So I am going to, I want to find out all the signs that are in, let's say, fair condition, and then I'm also going to see all the signs that are facing south, because we know that our south-facing signs degrade quicker than north-facing because of sun damage. So now I'm going to apply this filter. And now I'm just showing signs that are south-facing in poor condition. And now I can see this list of signs. I can see why it's in a fair condition. And then I can also bring up a table of that information. So it's telling me that on our whole system we have 878 signs that are south-facing and in fair condition, so that we may have to take action on them at some point. And then we could hand this information off to maintenance units. And we can do that by sending out a spreadsheet or filtering it even further. So I could add a filter and I could add another expression, and I just want to know in this maintenance station. So I can go to, this is the Salt Lake, I'll go to just the Salt Lake Metro and apply that filter. So now as I move over here, let's hope that there's actually some in Salt Lake Metro. So then we can really focus this. We can now bring up this table of information, And I could save this map and send it out to the maintenance shed and say, hey, you have 43 signs that you need to be aware of for this next maintenance season. And here's a list of them. Here's the type of sign. Here is the height and width to help for cost estimating. And we think that this is going to be a really powerful tool as we deliver it further throughout the organization. Like I said, we can save this map and then deliver it. And that's one of the real powers of UPlan as a self-service mapping tool. That myself as the GIS unit, I don't have to configure every single map. I can have a host of individuals that are users on UPlan. They can log in, they can create their own content through a little bit of training, and then they can save this information and then share it out to other people in their business unit. And they, as a heads up and a common operating picture, very quickly, they can click share, they can copy and paste this link into an email, and that quickly you have a live dynamic map and waiting in people's inbox for them to be able to interact with and start making decisions about. So I am going to turn back on. I'm going to turn on the speed limit signs here. Actually, before I do this, I'm going to go out to the crash map really quickly, because one of the powers that we have in GIS is being able to obviously overlay lots of different information on one map to make decisions. So that was an example of me just showing you one item, just signs. But now I want to show how we can take all of these different elements and all of our different enterprise data together and try to make a better decision. So I'm at the UPlan homepage, and I'm just searching for Utah crash information, and I get a host of maps related to safety, essentially, at UDOT. So how we're managing and monitoring our safety data. So there's this map down here at the bottom, and it's called Utah State Route Crash Locations. And this is a map of crash locations. It's a password protected map. And for the IT folks out in the audience, this is server-side protection. So the map object is public-facing, but the service is protected at the server level. So I'm going to log in here. So now that I've logged in, it's let me access to the data. This is an immense amount of data, so you have to zoom in to see the data. So I'm going to zoom in down to a route that we like to keep our eye on. It's State Route 6. It is a rural road. We've widened it quite a bit over the last few years. It gets a lot of weather. It's high speed. There's a lot of trucks. It's a fairly can I say a dangerous road in the state?
SR6?
Yes.
Yeah.
Yeah. So what I'm showing you here is crashes by severity. So 1 is a property damage crash, and 5 is a fatality. And we manage this data internally. We receive it from the troopers. We map each crash location, and then we give it attributes. Like I said, we try to evaluate how did that crash occur. So let's look for, I just want to filter for crashes that were roadway departure. So I am now just filtered on crashes that were a part of a roadway departure incident. So essentially the car ran off the road. So now we have a bunch of data about protection elements. So now I can add different data elements to the map. I'm going to use our keyword UDOT data. And we have a host of data here that I can, on the fly, add to the map. So let's look at some of our pavement, some of our protection elements. We have skid information that can help us evaluate crashes. We have barrier that we know can help us protect roadway departures. We have rumble strips. We also have signs. So now that quickly I've added a host of other data elements. I'm going to turn, maybe I'll just turn the speed limit signs on here, because we know that helps. So this is a speed limit sign, and I have it just labeled by the posted speed limit. Let me turn this skid information off. And now let me just try to zoom in here a little bit, and we can really start to look at this section of road and see where we have. I'm going to turn on a different base map here. I'll turn on the imagery. And now we can see that we have barrier on one side of the road. we have a rumble strip on the left side, and we have this crash here in the center. And as we zoom down the road, we can see other crashes. We're getting some conflicts here. Maybe I'll turn rumble strips off. That's probably a little bit better. But as you can see, we have crashes located, and then we can actually see where we have barrier. So we're trying to use all of this information together to solve some of maybe the specific problems that we're having with maybe roadway departure on this section of road. You know, and then we have other information coming out of another database, you know, skid information, and then we can see, you know, well, what is the problem with the section of road? Is it that our barrier is substandard? We can look at the barrier type and see it's a Jersey barrier. We can see the height off the road. We can see the skid information telling us that the skid is sufficient out there. So really just trying to use all this information together to solve that problem. So like I said, I'm going to move away from UPlan now. I have about 10 minutes left here. Okay, I'm getting the thumbs up. I can keep going. So UPlan is our enterprise GIS tool, but it's not our only tool. And we realized at UDOT that we realized early on in our UPlan development that you're not going to be able to develop one application or one map that satisfies everybody's needs. Like I said, we're a diverse organization. We have different levels of staff that need different things at different times. So we're using UPlan to help us focus map elements, but then we also have other tools that are helping us deliver this data. So Stan mentioned that URL, data.udot.utah.gov, and this is our data portal webpage. In a world where web addresses are plentiful, we wanted to give one simple URL out to our users and then have that be a jump-off point to all of our different GIS-type applications and places to find data. So really this is our splash page for GIS. We're trying to get everything related to GIS coming from this page. So what people can do here, they can search for data, they can click and they can download data in different formats. They can see the metadata about things, so it's telling me what is the information public, is it built off of our LRS, what the refresh cycle is, when it was last updated, who the data steward is so they can contact them, and then the domain information, so the description of the columns, what categories we're trying to organize our data into business unit categories to help us make the data better explorable. So really this is kind of like a wiki page of the metadata, the who, what, where, when, why type stuff about the data. We're finding that this is very important as we distribute this data out. People want to know where it's coming from, who I can contact, how up to date it is, because we're becoming a more data-driven organization, and that's really the only way that we're going to be more efficient in the future, is relying on our data and systems to help us make better decisions. And in doing that, they have to know where things are coming from. You know, garbage in, garbage out is our motto here. We're trying to reduce that and make sure that we're delivering authoritative and effective data. So this data portal here is a really good page for us. It's a good way for people to see frequently asked questions. They can see steering committee information. They can contact us. They can click up here and report a bug. So they could say, we have a data problem. It's about ADT. And if they fill this out, it actually sends this item to the data steward to say, hey, on SR6, I see the cars drop off. Is that right? So that's just a little bit about our data portal page. We have links to training information. We have a data guide here that is essentially a PDF of all of the data that we received, some descriptive information, and then all the data that we have in our catalog organized by categories. One of the things that we're going to improve on our data guide is confidence intervals around how the QC of the data, how accurate, oops, I jumped away from the page, sorry, how accurate the data is. So we're trying to give people a good idea of how accurate is the location information and how accurate is the content, meaning is that sign actually MUTDCB code 5 or whatever? How confident can they be that the content that's being delivered is correct? So we're working on that. So one of the other applications that we're using at the department to deliver this data is a tool, a straight line diagram tool called Linear Bench. And this tool was developed for us by a company called Gistic Resources, and we have taken it over in-house and we're managing it in-house. But this tool is really a research tool, and it's designed for a different audience. And it's really designed for a person that has a section of road in mind, and they can search for a section of road. It defaults to a milepost. So I'm going to say maybe I have a project coming up on this road from milepost 2 to milepost 10. And I can click enter. And now what you saw is you have a list of layers here that just refreshed. And what this is it's telling us here's a list of layers that has data, a list of layers from our catalog that has data on that stretch of road. So for example here, barriers came up, and it says event 6, so it's telling me that there's 6 sections of barrier along this stretch of road. So I can say, okay, I'm interested in barrier, I'm interested in projects, maybe I'm interested in sign information, I'm interested in pavement condition, maybe pavement messages. So now say I'm setting up for my project and I have all these different things that I care about. Well, we're trying to create this Google type environment where somebody can search for a section of road and very quickly get all the information that they want to know about that stretch of road. So I'll take just a little minute here to explain what you're looking at. So this is the straight line diagram as it's built out with data. Along the bottom here, you're seeing milepost information. So we're going from milepost 2 to milepost 10. That's what I set up in our filter here. You're seeing the layers of information over here on the left, barrier, projects, pavement condition. Up on the top here is a stick diagram coming out of our LRS. And I'm just using my mouse wheel here to zoom in. And as you can see, as I zoom in, I get cross-street information. And as I'm stepping through the diagram, you can see the map on the right is interactive. This whole thing is interactive. And I'll show you what I mean by that in a minute. So as I'm panning through the diagram here, the cursor on the right is moving on the map to show me where I'm at. I can click on any object in the map and it brings me up the descriptive information that you saw in ViewPlan as well. And the object is also being highlighted on the map. So the important thing about this is all the same data. So we're taking the same exact data and publishing it to many different places in different formats. We're trying to really observe an IT principle, a single source of truth or a single version of the truth. So it's a good thing to keep in mind it's the same data. So you can see the descriptive elements that manually collected about barrier, and then I can go jump to our road view. So now I'm going to launch our Road View Explorer, and it's going to take me to that stretch of road to that asset. So I can very quickly from my desktop see a picture of the asset as it was collected. And we think that's really important, that these photos were collected at the same exact time as the descriptive information of the asset. So you can really correlate the picture of it and the descriptive information that you're doing analysis on. So this is a photo that's heading up into Little Cottonwood Canyon, a really beautiful shot of the Salt Lake Valley. I can use the controls down here on the right to go forward and really look at this barrier to see if there's anything that comes to mind that's substandard or something that I really need to worry about on this stretch of road. I can see lane configurations. So really that quickly from your desktop you can do a relatively cursory field visit, and then also go back to your data and start to do other analysis. So from this straight line diagram tool, I can also do some filtering and analysis. So I'm going to, let's say I want to just know about my projects. So now I've opened up our advanced filter option. This is kind of a wizard-based approach here. So it kind of steps you through a number of screens that you need to do to make a query. So I'm going to filter on Project Manager, and I know that this gentleman, Richie Taylor, where is he? Richie Taylor has a number of projects in this area. So I'm going to say I want to filter on just Richie Taylor's projects. And you saw that this EPM projects line here is just changed, right? So now it's just showing me Richie Taylor's projects. Down here at the bottom, this is a table of the project information. And as I zoom out, this table also is interactive, so it's staying just one record because it's just Richie Taylor's projects. Now as I move up Canyon a little bit more, as I'm dragging the straight line diagram to the right and everything is moving, this EPM projects table is getting bigger and it's showing me the two different projects, as you can see. Let me actually move this map to the top view here because this route is more east-west here. You can see, I'm not sure how this is coming across in the webinar. Maybe I should just go back there because it's, let's just go that. I forget I'm projecting this and there's different screens and stuff. But anyways, you can see that as I click on an object in the table, it's highlighting on the map and it's also highlighting in the straight line diagrams. And now I can say, well, let's add these projects to the map. And you can see these little blue lines have now popped up on the map on the right. So these are all Richie's projects on the map. And say Richie has selected things about the section of road that he not only cares about for this project, but he cares about for every project. So that now you can very quickly jump from one project to the next and see that same information, see the barrier information. He can go to the table and he can sort the column and see maybe which sections of barrier are substandard. He can go to the signs and he can sort and see which signs are in which condition and get an idea of that information. So this is what we say is kind of a research tool that we're trying to empower really our staff level folks to do analysis about roadway sections. I'll just show this off a little bit more. You can just jump around to different projects here. It's a really interactive application. It's taken us about 3 years to get it to the point where it is now. But we see this as a really powerful tool. And really what we say is we have UPlan, and we have this tool. And how I gear our users is I say, if at the end of your project, at the end of your analysis, you want a map, you want to deliver a map to a person, then you should use UPlan, because this is a very traditional mapping tool. It's a very powerful GIS-centric tool. But at the end of the day, if you want a spreadsheet, a list of items, a punch list, so to speak, to hand off to somebody else, then use our straight line diagram tool, because it's a focus tool. You can search for information very quickly, and then you can export that information into Excel for use later. So I can select all the layers in the filter for this selected route segment. So from I-80, from 167 to 168, I can click Export. And down here on the left, a file has just been created for me. And now I can open that file up, and I have all of that information that I filtered or sorted on in an Excel file for me to do something else with. So now that we're able to take this information, put it in an application, make it highly available via the web for our users, they can then take it to their desktop and start doing some other analysis with it that's more focused on a project that can help us deliver better projects at the right time. And so I'm going to pass the time off here to John Guyman. He's a resident engineer here at UDOT, and he's going to show you really a next step of analysis and really a next level of staff usage of this data.
Thank you, Frank. Again, my name is John Guyman, and I am sort of, what I'm working on is taking some of this data that you've been shown by Frank and making it rapidly available to our guys in design. Just so you know, here at UDOT we get to build a lot of things, and that's fun. However, before we build, we have to design. And before we design, we have to gather asset information. we do a lot of orange and purple books in UDOT, and those are preservation projects. And the way we get information for these preservation projects is we send 2 or 3 engineers out into the field to the selected route segment with clipboards and tape measures and pens and pencils, and we spend a day or 2 days or 3 days or however many days it takes depending on the size of the project, and we count and measure up existing assets. So this will include the surface area of the road, all of the paint quantities separated by color and whether they're double or single stripe or dashed or dotted. We also count signs, the type of signs, manholes, water valves, and it takes a long time. And to be completely honest, it is rather mindless work. And it is also one of the most dangerous parts of designing a project, because you do have 2 or 3 different individuals who are out trying to cross the road at various points, measuring the road width, measuring up guardrail, which is sometimes right on the edge of oil, so traffic is flying past you, and your orange hard hat is only going to be so much protection. So the goal was to use this information that we've gathered for planning purposes and apply it to design, so we can design more accurate projects, but also we can be more safe as we design these projects. So I am going to go back to linear bench that we just saw from Frank, and I'm going to select a route in the state here, and one that's going to work well for our purposes will be US 89. And I'll just select milepost 390 to 400 here, and then again push enter. And okay. I'm going to go ahead and start over because these filtered layers are what Frank used to show you, and I do not want all those filtered layers in this. Let me try that again. So I'll go to US 89, milepost 390 to 400, and then again you can see all these different layers that have been updated based on that location and milepost. So today, for what I'm going to show you, I'm going to choose pavement messages and pavement striping. And again, these numbers next to it show you how many times, how many different quantities of these things you have. So when I push go, this will populate on the straight line diagram, and you can see where the pavement striping and the pavement messages are. Well, again, if I export this to Excel, and I select the layers that I want, and this time I want them both, I then get this file in Excel that shows me, maybe that'll help. That shows, so this tab is pavement striping, and you can see all of the information on pavement striping and pavement messages. Well, once we've gone out into the field and we have painstakingly gathered all of this data, we then build for each pavement preservation project we do what we call summary sheets, where we summarize the quantities based on mileposts for the entire length of each of these pavement preservation projects. And while counting the data is dangerous, actually formatting it and getting it into tables is also tedious, because you have to make a new table for each, not only for each project, but for each summary in the project. For example, you'll make one summary for your pavement marking paint. You'll make another for your manholes and water valves. You'll make another for your surfacing summary. You get the idea. So what we've created here is based on this information that we just downloaded from Linear Bench. We can generate this pavement marking paint summary sheet at the click of a button. So this will tell you the route you're on, Route 89. You can see the mileposts are broken down into half-mile segments. And you can see the solid 4-inch white paint. You can see exactly how many feet and how many gallons there will be of that paint. And this is really the end product before we can really jump into design and bid these projects out. So using Linear Bench and this Excel program, we save hours and hours of work for each pavement preservation project. However, we also increase safety drastically, because what we can do now with these summaries, again, this is only pavement marking paint, and we are in the process right now of creating this exact same process for all of the other summaries that we use. They'll end up being somewhere between 6 and 10 per project that this will automatically generate for us. Then we can take these summaries and we can take a U-plan map and go out into the field with these and quality check all of this data. And if it works out, if everything looks to be in line, then we can take these summaries and put them straight into the project. And so the time that we've spent in the field is drastically reduced. The time spent formatting this information is reduced. And our safety practices are improved, because we don't have to spend as much time running back and forth across the road in front of traffic, trying to measure width of the road and guardrail and everything else we do. So that is one specific example of how we can apply this very useful data into design that can save a lot of time and money. So I'm now going to turn the time back over to Stan.
Thanks, John. You know, I'm in asset management, as I've told you, and we wanted to know from a high level what we had, but we always thought there was more value to this information for design and construction and putting this information at the fingertips of everybody at UDOT, but everybody who has an internet connection. And so hopefully you've gotten a taste of what the future is going to be. Not only can we now manage our assets because we know what we have, but we can see them. We can make better business decisions, and we're integrating those into our business systems. So this final slide, I'm just going to give you a little bit of a flavor of future direction. The first bullet is business system integration. We have many different systems: our design, our construction, our maintenance, and they work much better if they're integrated. So we're working with Oracle right now of how to do that. That is going to be a challenge for us. It's about data governance, database management, and so we've embarked on that over the last year. You saw Frank show you the images and how valuable that is to be able to visually see that guardrail going up Little Cottonwood Canyon. You notice that he didn't try to measure the height of that guardrail. We're working on a project now that will be done this spring where we're going to superimpose the LiDAR in the image. So next spring, we'll be able to measure that height of guardrail from the image because the LiDAR will be behind it. Phase 2 data collection is going to start in the spring. I've mentioned to you what different kind of assets we're going to collect. Again, it's going to be some challenges for us. We put all this information primarily into Agile Assets, our maintenance management system. How do we overwrite 2012? Do we keep a separate file of 2012? So we have to work through those. The financial plan, for those who are familiar with MAP 21, requires a financial plan. Basically saying how much is it going to cost to maintain everything you have. So we're developing that right now as we speak. It's going to be GIS enabled. It's going to be, Frank is working with some folks here at UDOT, where you've seen all the assets in UGate. Now we're linking that with our construction bid system. So all those assets will have the latest bid price associated with them. And then we'll be able to tell you, and this will be done this spring also, we'll be able to tell you how many signs, what's the value of signs, what's the value of guide signs on interstates in Utah, what's the value of guide signs on I-15, what's the value of guide signs I-15 in Salt Lake Valley. So we'll be able to do that, and we'll be able to say this is our total value of our infrastructure. You know, that was one of the questions I asked, and we'll be able to tell you that this spring. And then John's shown you the future, I believe, of linking this asset information to our design processes. He mentioned time saving, safety savings. I showed you how we're calibrating the point cloud to put that right into our Bentley CAD products to design to. And then for those who have tried to guess the number of signs we have at UDOT, they're 97,000. We had no idea before this project. Now we know we have 97,000 signs, and I'll be able to tell you in about 3-4 months the value. So that's the end of our presentation. We can open it up for questions at this time, and we'll see if Mitch, I'm going to rely on you to help us out here on questions, or if we open up the phones for questions.
Yeah, I think right now the audio is muted for everyone. I'm not sure if we can open that up or not. If people, we just wait a minute or two. If people want to type in any questions, we can read those off for the group. Yeah, I guess one thing maybe I was going to ask again, maybe it was covered a little bit in the beginning, and I think you talked about in your first few slides, and it's something that I get asked quite a bit from either state DOTs we work with or people we talk to and other DOTs that aren't clients, but they're looking at these projects and trying to get, instead of like you talked earlier, like having data in silos, getting buy-in from different groups, I guess. Could you talk again a little bit about maybe some of the challenges you'd overcome internally within the DOT to get all the groups to get on board for a project like this?
Well, I admit your product was the hook. You know, we showed people your viewer. We showed them the LiDAR and the images all integrated, and that made my job quite easy. All I had to do is show them that. But having said that, it's a constant challenge for all of us to keep everybody going in the same direction. There's compromise when you have groups working together, and that's everybody. That's when the rubber hits the road, I would think. Not everybody gets 100%. When you work together, you get maybe 80%. And a lot of times, people intellectually they can understand that, but emotionally, when they're not getting 100%, they're getting 80%. That's when you have to have this a lot of communication, discussion, compromise. And so when I was saying that, Frank was nodding his head. So Frank and I know exactly what that means, and Mike does. So it's not all sweetness and light. Frank, if you want to add something?
Yeah, I think one of the things really to get people on board was just showing all the different business units how we can take one data element that's being collected and make it work for different purposes. Because, you know, designers want median information for different reasons, then safety wants median information then for different reasons, then maintenance wants different median information. Maintenance wants to calculate mowing areas and hand it off to the contractor. Design wants to know how much room do we have out there. Safety wants to know, well, is there a protection element on that median? How high is it above the roadway? So one of the big wins is for us, really in our GIS group, to show them now that we have this data, we have this tool, so we can take it and we can make it work for everybody. We can repurpose or repackage the data in different ways. So that was one of the things, and really, that was a big success for us, and that, we can get it, and it's not just going to go into a database and live there and nobody can access it, but we're going to be able to get it, and we're going to be able to distribute it effectively to lots of different people.
I had somebody text me a question while we were speaking, and it's a very good question. When Manly goes out and collects this information, they finished in the fall, late summer of 2012. It was out of date the very next day, right? Some things change. And so the question is, how are you going to update this information? And I've mentioned that we're going to go out and collect it again, 2014. We're going to collect it in 2016. And the real answer here is this integration that I showed you on this last slide. And what I mean by that is, wouldn't it be great is when John Guyman designs a project for us, a contractor bids it, contractor builds it, wouldn't it be great if all of those features went from the construction as-built documents into our Agile Asset System that then pulled it into what you saw Frank present, UDOT plan? Well, that'd be wonderful if it happened, and that's what the future may happen. But it's going to take a lot of work to get accurate as-builts that can be identified by assets, that can be put into our Agile system, and then into UDOT. That's one thing. That's for contractors, but maintenance people go fix signs every day. Well, wouldn't it be great if they have an app on their iPhone? You take a picture of it, geolocate it, and put in the attributes. Then they update the Agile Asset System. Right now, it's more paper and pound if it's even updated. So that's the second part. And so I've talked about the integration of the business system, Agile Assets, and our UDOT plan. So it's this integration that we're talking about. We're babes right now in the woods, and we got a lot to go. But people see that vision. People never even talked about, well, some people talked about that vision a couple of years ago, and everybody's just shook their head and said, yeah, right. But now it's becoming a serious conversation.
Dan, we do have a few questions if you'd like to go into some of the rest of these.
Oh, that'd be great, Rob, because we can't see them.
Okay. Well, first of all, you mentioned earlier about the about collecting pavement markings in the in the 2014 data collect.
Correct.
Are you looking at that as a possible leading to a standardization of evaluating those markings, or is it for other reasons?
Well, what I mentioned, Rob, I probably wasn't very clear, is we collected them in the 2012 cycle, but we're going to geolocate them all in the 2014 cycle, precisely X, Y, and Z for design applications. One of the things,
go ahead.
Sorry. One of the other things we're interested in, and I mentioned that this LiDAR has many possibilities that we're exploring, and one is what we call the intensity. If you have a reflective surface, you get more of that LiDAR image back to the receiver. Can you quantify that from a scale from 0 to 100? Make up a scale, if you will. And we're looking at that with 3M Manly and Virtual Geomatics right now to see if we can quantify that for signs. So in other words, if a sign has an intensity reading of 25 as opposed to 75, maybe we can correlate that to the condition of the sign. Well, designers are also asking us, is it possible to do that with pavement markings, striping, durable markings? Can you measure that intensity as you drive down the road automatically with your LiDAR? So we're looking at that too, Rob.
All right. So the other question is, could you collect centerline rumble strips? Can you determine a difference between the rumble strips and the stripes?
Yes, we do that. now collect the rumble strips, center line, edge of oil, and Frank is, I think, maybe going to show you something right now.
Yeah, I'll bring
While he's bringing that up, what's the next question, Rob?
How often do you collect pavement condition data?
We collect it on a 2-year cycle. We gave the contractor the option to collect half our roadway every year or our entire roadway every other year. And Manley proposed every other year the entire system, both directions.
Okay. Did you collect distress data in multiple lanes or only in the outside lane?
We collect only in the outside lane. And the reason why we do that is we believe that that's the lane that is the most severely deteriorated because of volume of traffic and especially truck traffic.
So I was just bringing up here that when they did collect the rumble strip information, they collected it by location. So they actually gave us, the GIS data exactly where the rumble strip is on the side of the road. So you can see we have center line rumble strips, we have left and right rumble strips. So they were able to determine where the rumble strip is on the section of road and then give us the correlating line as it relates to the earth. And then, we can also, to see that, jump to Road View Explorer to see that stretch of road, and we can see we have, rumble strips on the left and right and in the center there.
Thanks, Frank. I misspoke. I didn't know it was geolocated. I thought it was by section. Okay.
And that's important because then we can also do not only like an LRS analysis, but also like a spatial analysis on that as well.
Okay. When you talk about the edge of are you talking about the edge of the pavement, the edge of the shoulder? What does it mean?
When I said edge of road there?
Well, this is from earlier in your presentation. The question is, what is the edge? Are you looking at the edge of the pavement, the edge of the shoulder?
We locate, Mike, maybe you can help us out. We locate signs and guardrail, noise wall from edge of oil?
Yes. Yeah, it's most of the assets, if there's a distance factor, like how far the asset is from the edge, it's the edge of oil. So Manley went through and identified the pavement striping and then also the edge of oil, and then extrapolated out the distance from a sign to the edge of oil. So most of the time we're talking about the edge of oil.
Okay. So what accuracy are you collecting the data, and what was your desired accuracy when you started the process?
For location data, we wanted it within 5 feet. So we wanted, if there was a sign and we went out there on the earth and we hoped it was within 5 feet. For measurements, the accuracy that we find, it's within anywhere from 2 to 6 inches, Stan, is that fair to say?
Yes.
Which most of the time, all these accuracies are by far, for maintenance level, it's well within what's needed. If maintenance wants to go out and find a sign, if it's within 5 feet, 10 feet, they're going to find the sign. For design, though, on the other hand, obviously we want it as close as we can get it. So when we initially went out on the project, we were looking at these items more from a maintenance standpoint, and so the accuracy is well within what we need. But as we go into design, then we're evaluating again how well that plays into.
Okay.
Mike, you mentioned disincentive. Rob, we're going to have incentive disincentive in the contract.
Yeah, one of the things that we did add into our contract were there were 5 elements out on the road that we had an incentive and a disincentive attached to it. Things related to the cross slope, to the surface area measurement, location data, etc. And so it was a motivation for Manley to have high quality as they went out and collected various attributes. And it worked out really well because, again, it gave us a benchmark to look at and to say, did we meet these? And by far, the incentives were met by Manley and turned into a good thing.
All right. Is the sign data collected using LiDAR? And if so, how do you update the data if you fix the condition of a sign in poor condition once it's replaced or the problem is solved? Who changes or updates the data in U-Plan?
I mentioned that before, Rob. I basically said the goal would be when a maintenance foreman changes a sign, they update their database, which is Agile Assets, and then we upload that every night into UDOT U-Plan. It becomes
so you're working
more
on something to do that.
Pardon me?
So you're working on a process so that will eventually be the case?
Yes, that's the long-term goal. There would be training involved with everybody in maintenance. When they put a sign in, they have geolocated that sign. They put the proper attributes to that sign. They filled out the Agile Assets OMS system correctly. But then the same thing applies at a much greater scale when we have a reconstruction project where we replace 300 signs on a project. And there, we would hope to have this link between our construction database and our Agile Assets OMS system. That's the work.
And you mentioned, I'm sorry, go ahead.
That's the work that we're doing with Oracle right now, of creating a strategic direction for our IT division to think holistically, to have databases that are linked, common LRSs, common data governance. That is going to be a very big challenge. But we wouldn't even have took it on. But now people can see the vision. So we are starting to do that. I think Frank wants to mention something on the screen now.
Yeah, I just brought up, this is a big question. That question right there touches on a lot of this project. How are we going to keep the data up to date? Where is it going? How is U-Plan holding the data, or where is it all? How's this all working? And this is a conceptual diagram that shows really our data flow from its source business systems and how it gets out to U-Plan. So we have an emphasis, and I'm just going to spend, I'll do this real quick. We have an emphasis on really source systems here. These are the operational systems that own that data. So PONIS is our bridge management system. It holds all the bridge data. So all the bridge location information that we receive from Manvely, we populated PONIS with. EPM is our project management database. So where we map all of our projects and say what kind of project it is, how much it's going to cost, when it's going to happen. OMS is our operational management system. That's our asset management database. That's built off of Agile Assets data. And 90% of this asset data went into this database here. So this is the operational system that's transactional. There's a number of users that update data in the system. So we hope that when a sign is replaced, the maintenance unit will go log into the OMS database, update that record with the new type of sign, when it was replaced, what the current condition is. And then what we do from each one of these source systems, we nightly or weekly or monthly, depending on the type of data, pull it into our enterprise data warehouse, which we call UDOT. This is our behind-the-scenes data warehouse where we use a combination of technologies to geospatially locate the data. And then once we get it into really our apples-to-apples, our common formats, then we publish that data out to U-Plan and to our other applications. So the data portal and Linear Bench and U-Plan, they're not really per se hosting the data. They are really how we're delivering it. And we have an internal architecture here where we're hosting all of the data, and mainly because our data is transactional. It changes every day or every week. So I hope, I just wanted to bring this up because that's a big question, and this is there's always questions about this kind of stuff.
And to answer the first part of the question, it was how do we collect the signs? And that is, it's a combination of the visual and the LiDAR. The LiDAR is used for the GPS location, for the measurements, width, height, and then the images are used for the condition data and then also just to verify other aspects of the attributes.
Stan, if you have a few more minutes, we do have a few more questions. You tell me when you want to stop.
I think we're good until another 25 minutes, right, Rob?
All right. Stan, you mentioned the Manvely workstation, but what other successful strategies did Utah use to create buy-in amongst all of the different functional areas to get them to work together towards this common goal?
UDOT U-Plan was also very important. It's also this visual. I keep on going back to that. You know, some of us are very articulate, but I'm not one. But if you can see it on a map, and what Frank has done with John Thomas to create UGate U-Plan with ESRI, you know, you don't have to be a visionary to get buy-in, to see where we're going, to see collaboration. And even it feels really good when you talk with somebody at UDOT who is the type of person who the glass is half empty, and they say, no, I get it. This is where we're going. And so even those type of folks, Rob, see it visually, present it through UGate U-Plan, and then what John Guyman is doing about tying that back into our bread and butter, design and construction. We always wonder if we're at the top of the hill and ready to roll the big boulder down. So there's some days when we think the boulder's going to roll down on top of us backwards. And other days we feel pretty good. So it's a constant communication. I'm just rambling now, so I'm going to stop. I'm going to let Frank talk.
You know, what we talk about here that, you know, we internally on this project have drank the Kool-Aid, and we're trying to get others to drink it, and we're actively doing that. I don't think we want to make everybody think that we have everybody at UDOT owning and using this data. You know, it's a little bit of an acquired taste. I don't think anybody sees this pile of data and thinks it's unvaluable. I think everybody sees the value in that. I think it's just the way that we're gaining more support because of the way we're able to deliver it. The way we collected it was a key thing as well, because everybody wants this information, and we really saw an economies of scale of having a vendor that could drive the system once and in one single pass collect all of these things at once. I think that was a really big win for us, where a lot of people jumped on board because we said, you know, we have this vendor that can collect pavement and signs and walls and all these different attributes about all these different things that all of the different units can use. And we didn't hit the mark on every single thing, but we're learning. I mean, this is the first time we've done this, and really the first time that all of these units came together to do an enterprise data collection. So that one single pass was, I think, a big thing as well. Still there, Rob?
Yes, Stan, let's see. The next question would be, you mentioned plus or minus 8 inches in accuracy, and then finally learning you had plus or minus 3 centimeters. What was the desired accuracy you were hoping for when you first began, and then what's the minimum you need to consider the data useful?
Yeah, that's a good question. When we first saw the point cloud, the accuracy Manley told us was plus or minus a meter. We knew that was fine for asset extraction, but we couldn't design to it. So the plus or minus 8 inches is noise from the Velodyne 64. We cleaned up that noise. So now we can do concept type of reporting, concept type of projects. The next thing that Virtual Geomatics did was they transformed the entire point cloud to plus or minus 3 centimeters. And that is absolute accuracy. That's X, Y, and Z, latitude, longitude, elevation. And that is the accuracy that we need to design, plus or minus 3 centimeters. So that's the revolution. I use the word revolutionary because it is. Everybody thought that somebody had spiked the Kool-Aid that Frank mentioned earlier. So we added tremendous value to already a very valuable project, a product of the LiDAR. So it's a little bit complicated. I used a bunch of numbers there. Precisely, but the bottom line is we hired a survey company that we work with all the time here in Utah. They put their stamp on it, their engineering stamp on it. They stood behind it. They signed it. They said, this is good. Use it for design.
Hey, Rob, that's a tough question, too, because we're taking this data and we're using it at many levels. And for really performance measure, horizon type analysis, we don't need it to be engineering grade. We're collecting this at a mapping grade, a planning level grade, and we, for all intents and purposes, if we can use the location information and hit the sign with a rock when we're in the field, at that level, it works. So we're really pushing the limits of how we use this at all different levels, and different levels of the organization have different precision elements. But we're finding that this data has been delivered in such a way with the LiDAR that we can use it at all these different levels.
All right. Well, let's see here. It says when you collect crash location, signpost locations, etc., do you collect the GPS data of the location or mileage data?
The officers in the field collect the milepost information. So we're using, and I don't want to overspeak on this because I'm not entirely sure what I'm about to say next, but I think there's a pilot program going on right now for officers to GPS, to use a unit in their car to actually GPS the position of the crash. So usually it'll be where the trooper's vehicle is sitting in relation to that crash, and they hit the button and it gathers that point. So some of our crash locations are coming in via GPS from the field. When we first started that, we got a lot of GPS locations from the patrol parking lot. So we're doing some training there, I think. But it's a combination of GPS in the field and then also a form that the officer fills out with milepost information. And then all of that information is funneled back to Central Traffic and Safety here at UDOT, and there are a small team of mapping technicians that use a heads-up mapping tool to actually really digitize and plot the crashes on a map via the milepost information or the address or the really any descriptive location information that was given on the form. So I hope that helps. And that auto-populates, they're using that heads-up mapping tool, and it auto-populates our safety management system database. So it attaches a accurate location to the crash and the spatial location in the database. And one key thing that I want to point out here, this actually bleeds on that, and I promise I won't blather too much on this. But when we collected all of this information, we asked Manly for a couple of different things. We asked them for route and milepost information, so we gave them a GIS file of our LRS that had our LRMs, our linear reference measurement, or our milepost information on it. They gave us the X, Y, and the elevation. And we really think it's important to have both the X and Y and the route and milepost to be able to help us keep this data up to date in relation to changes in our LRS. Because if we have a firm XY, we have some procedures in place here that can tell us what the new route and milepost is. So we're really transitioning here at UDOT into cataloging our enterprise data by both current LRM and also the current XY. So we really think that's going to help us go forward with a robust LRS system to keep all of this data up to date with changes in routes. So that was a key thing that we asked from a data side of things that's going to help us in the future.
All right, let's see here. The next one would be, have you created a formal marketing program internally at UDOT to ensure a strong cadence of communication within the DOT? If not, do you plan to create a regular communication progress or communication process internally? And I would add to that, what about externally? I know that you've had some conversations with the policymaking folks. So what do you see as that communication role both internally and externally?
I'll start, but then I'll let Frank wants to answer this question, so I'm going to give him some time. We had a conversation with one of our regions yesterday, and it was about data quality. And he was concerned that how good is this data and where is it from? So Frank showed them where it came from, who is the management, who is the data owner. And he still wasn't satisfied. So we talked with him after our presentation, and he said, "No, what we need a data governance." And I said to him, "Dave, you know what that means?" And that means everybody follows the same procedure on how to collect it, how to attribute it. That means a lot of compromised communication, organization, policy, procedure. And he says exactly right. That's what we need. You guys are exploding this issue on the amount of data, and it's great. We need to make sure we're all going in the same direction. So I'm answering your question in a roundabout way, sorry, but it's this idea of we haven't set up a data governance here at UDOT. We do not have this hierarchical structure of who's responsible for it and who has various parts of this. And we do not have a standing committee on this issue. We do not have the same thing on integration of databases. We don't have this communication in place today. We're trying to build it. But what it's shown us is we're going to take full advantage of this new world. We're going to have to do things that we don't do very well at UDOT, which is create policy, procedures, organization, flow charts, responsibilities, follow-up, accountability. So I don't know if I answered the question about communication. I'm going to let Frank try.
I think our presentations are our best communication material right now. I think we do need to do some work on having a good outreach tool that's consistent that everybody can use. I think we're working on that. You know, it's a small team here, and a lot of this stuff is sort of other duties as assigned type work too as well. So we need to develop definitely a more transparent and better communication tool other than these presentations to deliver this data. You know, like I showed the metadata information on each data element from our data portal. So we have people assigned to data elements, but we're transitioning as a department here to maintain this data. So we don't have a good outreach. Our outreach tool are these presentations right now, and we're doing a lot of groundwork of going out to each of our regional offices and doing presentations and trying our best to communicate this. But it would probably help us to develop something, a more formal packet, so to speak, that we could hand out. So maybe we should think about that.
Well, I can tell you that a lot of these issues are going to be addressed during the USDOT Datapalooza and GTMA annual meeting in June, because trying to answer some of these questions are going to be vital if this is going to expand beyond just what Utah has been able to accomplish. So we'll certainly be interested to see how this progresses internally there as well. We do have a few more questions. Are you using Esri roads and highways?
We're not currently. We have an LRS tool that's homegrown. It's our biggest success and our biggest challenge right now because it works for what it does for us right now, but we know that it's antiquated and that it needs to change. We use Esri software in helping us maintain our measured polylines, our GIS data for our LRS. We're getting a demo of roads and highways next month. We know that tool is a really good tool, and there's a lot of things there that I'm really interested in. You know, the logic of how your route events can change in relation to a change in your route. You know, there's a lot of good tools that they have there that just say, hey, I want this accident to move or stay put. I mean, there's a lot of tools that they have built in. You know, I think as a department, our IT enterprise, we've done a lot of custom development over the years. And as a lot of our programmers are retiring or moving elsewhere, we're finding that it's getting really challenging to maintain this stuff. So we have a good dynamic of a COTS-based enterprise, you know, and off-the-shelf tools, and also a combination of custom stuff. But we're not using roads and highways. I know a lot of DOTs are having a lot of good success with that right now. But we're LRS is something that I've sort of put my head in the sand on right now because we have bigger fish to fry.
What is the plan for adding further analytical capabilities to the GIS system so that scenario analysis based on the level of funding and level of service can be ascertained?
That is a great question. One of the things that we're really trying to do with our next steps in GIS is we're trying to, we've shown people, hey, we can put all this data on a map, we can shotgun this data out to you and get it out, and you can do your own analysis. But that's not enough. We need to focus our GIS product into our business workflows. We need to know exactly what they need to know about signs. You know, what is the decision, what is the punch list, or what is that actionable item that they need to know about signs? And then we can build an application or just a simple map query that every time they go to that map, it's going to tell them exactly what they want to know about signs. So the real next steps is really us learning more about our business. You know, we're a diverse organization. We have a decentralized management techniques. So it's our matrix organization around a lot of things. So it's our next steps with GIS is not just using a big shotgun tool, but trying to focus the applications that we have out on UPlan to really answer specific questions about assets.
I had a comment too there, Rob, on this. Is I mentioned that for the first time we're going to be able to figure out the value of our assets. So we have our estimator working with Frank in GIS and through our bid system to determine what's the value of our signs, what's the value of our guardrails. Our real problem here at UDOT is we're a bunch of engineers. And now we have a few GIS people. We have no economists. We have no statisticians. So this is a foreign language to us. And that's going to be, and that's very difficult to do. So, you know, could I hire one economist? Yes, but there'd be one economist and we'd have 300 engineers. And so we'd be talking different languages. So we have to make this transition from being strictly civil engineers designing and constructing roads to, I believe, economists, statisticians, business analysts who can say, you have all of this, you have this value, this is the cost to maintain it, this is how your value depreciates over X number of years, and this is what you're going to have to spend to make that depreciation go straight, if you will. And I don't think many DOTs across the country are there yet to make that leap from engineering to analysis.
Sounds like a great opportunity for a company that was willing to develop those tools for multiple states.
It would definitely be an opportunity for a company to be able to come into a DOT and say, you have all this stuff, let me show you how you can report it from an economic standpoint instead of an engineering standpoint.
And I think with MAP 21, with the performance measures that we're going to have to do, we're going to be forced to, you know, do more of that sort of targeted analysis.
We're running short on time, so I'm going to try to cherry pick some of the rest of these. What metadata standard are you using?
Our own. We do fill out a lot of the FGDC metadata requirements in our SDE database. You know, we're really trying to manage the basic 5, you know, who, what, where, why, when type stuff. We don't have a real specific metadata requirement. We're using sort of a wiki-based approach. We know that we need to communicate effectively who manages the data, how it's been updated, what's the degree of accuracy. So we fill out all the FGDC stuff on that. But we're trying to find metadata is something that we need to do a better job with. And I know Esri's coming out with an open data portal that is hopefully going to help. We're looking into that. So that's something that we need to do a real, and it gets into a lot of these questions. Well, what is the data? I guess I should rephrase this and say we're trying to accomplish metadata for UDOT in a way that our engineers can understand what's the most appropriate use of this data element. So it's I guess our metadata efforts are a little less GIS-centric and more people-oriented, of trying to put it more in layman's terms of you can use this for planning level analysis and you can use this for design.
It goes back to what I said about there is no overarching strategy on data governance across the department. And if you mention that word data governance to 99% of the people at UDOT, they have no idea what you just said. And so it really starts there. And that's the great thing about working at UDOT is if you want to try something, upper management supports you. But the bad thing is there's very little coordination across the department when we do these initiatives.
Stan, are you using the Manly data collection for your HPMS submittal?
We are. We're doing it several ways, and I might have Frank and Mike jump in. But we actually are going to each one of our sample sections, 2,400 of them, with Manly's workstation, the LiDAR, their images, and we are attributing correctly all 2,400 of those. So that's a great thing. We don't go out to the field anymore. We do it from our desktop. The second thing is, for the first time, I reported to Carlos Braceras yesterday, our director. We work on the strategic direction every year, and every year he asks me, how many more lane miles do we have? And it's always just me scrambling, or Frank. And I was able to report to him the lane miles because we go through the Manly workstation, images, and LiDAR, and our HPMS individual is saying, that's a lane, that's not a lane. So for the first time, I was able to give Carlos a high five and say, we've got it right. It was wonderful. It was just a wonderful thing.
I think
on your homepage, I'm sorry, go ahead.
No, I was just going to say, I think that's something I'm really excited about with this data is, you know, it's being used for a firm deliverable this year, and I think that's something we can show that we're getting some value out of it. You know, but it does take some work, you know, that we received the data from Manly and we got what we asked for, very detailed data, and now we're having to make it make sense for maintenance, make sense for HPMS, make sense for project development. So it takes a little bit extra work, but in the long run, it's going to make us have more effective programs.
And this will have to be the last question. On your homepage, you show a link to aviation projects by UDOT. Have you used LiDAR on these as well?
We have a pilot program, a pilot project we did with Manly last year, John Kaya and I and Mike Butler. They did the Cedar City Airport, and we are really excited about the possibility there of having us do not only the pavement condition of the runways, the approach, the taxi, but also the assets with LiDAR. But as you know, the funding and the responsibility lie with FAA, and our guys are slowly introducing this to the Denver office that has responsibility for Utah. We haven't gone any further than that.
Well, that's all the questions that we have time for, so I'll turn it back over to Mitch or to Stan to wrap it up.
Take it away, Mitch.
All right. Well, I appreciate everyone again, and we will send out a link. I think one might be automatically generated with the recording of the webinar. So one last reminder, I guess, or little item for TRB coming up. We'll have booths. 322 is our booth number. Feel free to stop by. I love the meeting one. They haven't met in person before. And I know that's it. Again, I appreciate everyone's time for joining us today.
Well, Mitch, people at UDOT want to thank you for giving us this opportunity. And Mitch, I'll send you that PowerPoint in case anybody wants to get those embedded links.
Yeah, I will send out any information like that, the PowerPoint and the video, the webinar. And if anyone has any questions, feel free to contact me via email or phone. So thanks to you, everyone at Utah, and thanks for Rob for setting this up. And like I said, any other information, if there's any other questions that weren't answered, feel free to email me, and I'll make sure to get in contact with Stan or have him contact you directly if that's all right, Stan.
Yes, that'd be great, Mitch.
Okay.